Okay, so on this section, we're going to learn simple interest and compound interest. So we're going to look into the section 2.1. We'll take a look at the difference between simple interest and compound interest. So simple interest only principal, or you can say initial investment. Interest. But for compound interest, both principal or initial investment and interest earned from the previous period and interest. So the main comparison is compound interest. The money is growing at a faster pace. Grows faster pace. So from the investor perspective, compound interest is better. So we're going to look into the detail about these two different financial instruments. Okay, so nowadays very few banks pay interest based on the simple interest. Instead, they pay interest based on principal called compounding. It's same thing as compound interest. I mentioned from the previous slide, the difference between simple and compound interest is simple interest grows slowly. Compound interest grows at a faster pace. Or the compounding speed up the process. Simple interest earning interest on the principal or in the initial investment amount. Compound interest is when your principal and any earned interest both earn interest. Meaning earned interest from previous period will earn interest in the near future. So if you look at the simple interest formula here, the total amount of interest I is calculated using P times R times T. Here P means principal or initial investment. R is annual interest rate. And then the T is the time in years. Okay, so interest equal to principal times annual interest rate times 20 in years. And then the next formula is total amount of money obtained. So ending balance, A, right? Ending balance. A here is calculated using the following formula. So ending balance A equal to principal plus principal times interest rate times 20. So A here represents ending balance. After T years. The principal added interest earned becomes the total ending balance. Now let's take a look at this simple example here to understand how the simple interest works. Consider this example. You begin with $100, invest at 10% annual interest, find ending balance. After 1 year, meaning 20 equal to 1. So the ending balance, so here the principal amount is $100, interest rate is 10%. 10%, that's 0.1. And we just find out the ending balance. So ending balance equals principal plus principal times interest rate times 20. Principal is $100 plus 100 times 10%, which is 0.1 times 1. So this is 100 100 times 0.1 times 1, that's 10. So the ending balance is $110. And 2 years, that means 20 equal to 2. Principal is the same, 100. Rate is the same, 0.1. So the ending balance A equal to P plus P times R times T. That will be 100 plus 100 times 1 times 2. So that's 100 plus 20, and that will be $120. And when time t equals 3 years, P principal is still $100. Rate is 10%. So the ending balance equals principal plus principal times rate times time t. So it's 100 plus 100 times 1 times 3. That's $100 plus $30. After 3 years, you get $130 as the ending balance. As you can see, as year goes by, interest go up by $10. And time t equals 4. This was 100 raised 1. Ending balance is principal plus principal times RT. That's 100 plus 100 times 0.1 times 4. That is 100 plus 40. So this is $140. When time t equals 5, and principal is 100, rate is 0.1. So ending balance is principal plus principal times RT. So that's 100 plus 100 times 0.1 times 5. That's 100 plus $50. So this is $150. Now let's jump to 10 years. 10 equal to 10. Principal is 100. Rate is 0.1. So ending balance is principal plus principal times rate times time t. So that's going to be 100 plus 100 times 0.1 times 10. So if you look at the other one, 100 plus 100 times 0.1, that's 10 times 10, 100. Now we end up with $200. Notice that 10 years is double, right? So at the 10-year mark, the money doubles. 10 years is doubling time. For 20 years, as you can see, we should see a tripling result, right? So P equal to 100, I equal to 1. So ending balance equal principal plus principal times R times T. That's 100 plus 100 times 1 times 20. That's 100 plus 200. Turn out to be $300. And as you can see, compared to the initial investment, $300, that's tripling. So time t equals 50 years, principal equals 100, raised to the same 0.1, and have ending balance equal to principal plus principal times RT, 100 plus 100 times 0.1 times 50. So we end up with, okay, so this 100 plus $500, that's $600. So after 50 years, the money becomes 6 times as much as the initial investment. So now let's take a look at this example number 1. So in this example, we have you borrow $15,000 from your friend. Okay. After 2 years and 3 months, you repay the loan. You pay the loan by giving your friend $18,000. What was the simple interest rate you paid? Okay, your friend is nice enough not charging you interest based on interest rate, but you know, make money, so you pay back with more money. That means, and intrinsically, you pay your friend some interest. So let's see what kind of interest rate we're looking at here. So using the formula here, so this $15,000 is principal initial investment. At the end, the ending balance is $18,000 because you're paying back $18,000. Okay. And time t here is 2 years and 3 months. but time t got to be in years. So what we're gonna do is turn 2 years as whole number 2. 3 months is 3 over 12. So it's a quarter year. 3 months is a quarter year. So 2 and a quarter. And this turned out to be 2.25 years. So important, right? 20 must be expressed in terms of years. So right here, so we get a solve for rate, right? The only thing we don't know is interest rate. We solve for that. So ending balance equals principal plus principal times rate. The principal is 15,000, so we get 18,000 here. So 15,000 plus 15,000 times rate. We're looking for that times t. That's 2.25. All right, so we will solve for the r, right? So first of all, we subtract 15,000 on both sides of the equation. Cancel that, so we end up with so we get 3,000 on the left. On the right is 15,000 times 2.25. Let's keep it as is. Let's see how we handle this in a second. Times rate. And now here we're going to solve for r. So r equal to 3,000 over 15,000 times 2.25. So divide both sides equation by the number in front of the r. Right? So we're going to get a rate here. So again, we can use Excel. So I'm going to show you how to get this in Excel. So 3,000 divided by 15,000 times 2.25. And we end up with approximately, for decimal place, 8.89%. So yeah, paying your friend 8.89% interest. So this is approximately equal to 8.89%. Okay. Yeah, so that's basically how we solve this. And now that's simple interest again. So now let's take a look at compound interest. And compound interest is better, right, compared to simple interest because the money works harder in the compound interest case. Both the principal and the interest earn interest. We always earn more interest in the same condition with the same interest rate R and time t. Now, first of all, let's look at the formulas. Right? Calculate compound interest using this formula. A still represents ending balance. So the ending balance equal to principal times open parenthesis 1 plus R represents annual interest rate, and then N represents number of total compounding periods per year, and then T here represents the time years. And P represents the principal. So we basically just apply the formula. So here compounding periods, right? So if it is compounding monthly, then number of compounding periods per year is 12. And you're getting interest on a monthly basis, so number of compounding periods equal 12. If it is compounding weekly, then n equal to 52 weeks. Okay, so you receive interest 52 times. And if it's compounding daily, you receive interest 365 times. Compounding period is 365. I'll just give you an idea of how the compounding period works. now let's look at example here. All right, so first of all, we have find an ending balance for $100 invested at 10% interest compounded monthly. So we have this right here, given the initial investment principal $100. So this $100 is the principal on initial investment. Interest rate is 10%. The number compounding period is compounding monthly and equal 12. Right? Compounding monthly meaning compounding period is 12 per year, and time t equal to 6. So here the only thing we don't know is ending balance. So we apply the formula ending balance equal to principal times 1 plus interest rate over number compounding period over number compounding period times time t. Okay. So that is the formula we are using. So here the principal is 100 times 1 plus the rate is 10% over number compounding period 12, and as the exponent is 12 times time t, that's 6. Meaning you are receiving interest 72 times over the life of the investment. 12 times 6 is 72 times. And we're going to put into the calculator 10% over 12 and raised to the 72nd power. So this is what we call exponential equation or exponential function. And we're looking for ending balance. I'm going to show you really quickly in Excel. So you go to Excel, put in the equal sign 100 multiplied by 1 plus the rate is 10% over 12 raised to 12 times 6. If you want to do that, I will do it. All right, then you put in the enter. Okay, and let's see, $2 sign. And so since we're talking about money here, so the rounding rule is always rounded to 2 decimal place, rounded to the cent. Right? So here it's $181.76. That's how much it is after 6 years. So it's $181.76. We'll quickly double check. 76 cents. That's right. All right. So that's basically we are applying this compound interest formula, and compound interest is exponential function. This is the base. If you look at it, the base is 1 plus Rn exponent nt. That's how we apply what we learned in chapter 2 in this section. Okay. Yeah, so this is the nature of the compound interest formula. Example 3, find the ending balance when the find the ending balance $250. So this 250 here should be what we call the principal. Principal equal to 250. Invest at 6.5%. That's the interest annual interest rate 6.5%. And for 8 years, compounding quarterly. So time t equal 8. Now compounding quarterly, there are 4 quarters in a given year. So here n equal to 4. So one more time, we're looking for the ending balance. So ending balance equal principal plus rate over compounding periods close parentheses average NT. So read the question and analyze the situation and write down the number as in a corresponding symbolic form, and then eventually we just plug into the compound interest formula and get a result. So here we have 250 multiplied by 1 plus rate is 6.5% over 4. An exponent, that's 4 times 8 years, 32 power. And again, you need to either use Excel or calculator to do this. So we get a 250 multiplied by 1 plus 6.5%, that's 4 over, and raised to 8 times 4 times 8. Okay, so this is the Excel input. Once you have this the answer, get the result. So this turned out to be $418.75. So this is the ending balance, $418.75. $418.75. So this is the compound interest. Now let's look at example 4. So we have $185,000 left in the account for 5 years, in the account paying 4.22% interest compounded daily. Okay. How much money would be in the account? So we're still looking for the ending balance. So here, 185,000. That's principal. And we know time t, right? Time t is 5 years, and so it's 5.25 years. So turn in decimal for the simplification of the calculation, and then interest rate is 4.22%. And then you can turn, if you want to turn in decimal, that's okay, but we can keep it as a percentage. Compounding daily, that means n equals 365. So this is daily compounding. How much money will be in the account? So now, again, we apply formula, the balance equal principal times coefficient is 1 plus alpha n t. We're still plugging all the numbers, 185,000 multiplied by 1 plus rate is 4.22% over 365. Exponent is 365 multiplied by 5.25 years. Okay. So one more time, we just use Excel calculator to do this. So once you understand the principle and also the formula, the rest of the stuff is done easily. 185,000 multiplied by 1 plus 4.22% by 365 close parentheses raised to 365 times 5.25 close parentheses. And once you have the right input and the results will be straightforward. So $230,878.83. So the ending balance is $230,878.83. 230,878.83. Check. Yeah, 83 cents. That's good. So this is how much money you end up in the account in the current situation. Now, $1,250,000 is left in the account for 11 years and 5 months. In the account paying 2.58% interest compounding monthly. How much money will be in the account? So now we can figure out this. First of all, let's list all the given information here. So this $1,250,000 principal on initial investment, and we get 20. That's 11 years and 5 months. We get 22 years. So this turned out to be 11 and 5 over 12 years. 5 months are 5 over 12 years. So this is a tricky part. We have to always make sure, it's in years, right? In terms of unit for time t. Rate is given, rate is 2.5%. And here this is 2.625%. However, H is 0.625, and it's definitely easier using the decimal numbers in this case, so we'll do that. Compounding monthly, so that means number of compounding period is 12 per year. So now again, we apply the ending balance formula. Ending balance for principal times interest rate over number of compounding period over n times raised to n times t. So here we have 1,250,000 multiplied by 1 plus the rate is 2.625% over 12 and raised to 11, right here 11 and 5 over 12 times 12. And here we can simplify this a little bit. So 11 over 12 times 12. So turning this number into improper fraction, 11 times 12, adding 5. So we get 11 times 12 and 5 over 12 times 12. And 11 times 12 to 2, and then so it's 132. And 132 adding 5 is 137. It's 137 over 12 times 12. So the exponent is 137. So that means we can just turn this into 137. So this is 1,250,000 1 plus 2.625% over 12 raised to 137 power. Let's see what this is. Go to the Excel. So we get 1,250,000 multiplied by 1 plus 2.625% over 12 and raised to 137 power. And then we should get a result right away. That over there. So this is 1,686,000 and $244.30. 1,686,244. So the answer here is 1,686,000. $244.30. $244.30. That's what the ending balance is after these 11 years and 5 months. Example 6, you need $25,000 to buy a car. So now you are given the ending balance, right? So this 25,000 should be the ending balance A, because that's probably in the near future. How much do you have to put in account yielding 3/4% compounding monthly in order to have 25,000 in 5.5 years? So now you are looking for the initial investment, right? How much money you have to invest in this account to get $25,000 in 5.5 years. So now as you can see, we get ending balance. P is what we're looking for, and then the rate is 3/4%. 3/4 is 0.75, 5.75%, 0.05. Going to more decimal. Time t here is 5.5 years. It's 5.5 years. and then interest rate of that. So we pretty much ready to solve for the P, right? So ending balance here equals principal times 1 plus the rate over the period raised to NT. One more time, ending balance 25,000. Principal, that's what we're looking for, or initial investment. Rate is 5.75% over number compounding period, compounding monthly, so equal 12, and then raised to 12 times 5.5. And you also solve for this P, which is have to divide both sides equation by the exponent, 1 plus 5.75% over 12. And 12 times 5.5, that's 66. So you can divide both sides equation by that. Cancel that, and the principal is by itself, P is by itself, so you get 25,000 over 1 plus 5.75%, 12 raised to 66 power. And let's see what this is. So get a 25,000 by 1 plus 5.75% by 12 raised to 66 power. You want to do open parentheses 12 times 5.5, that's okay. Alright. And then let me double check. 12 times 5.5 should be 66. So right here, so the ending balance to be 18,000. I mean, the initial investment is $18,235.70. $18,235.70. $18,235.70. Okay. So this is the initial investment we have to put into this account in order to achieve the financial goal, find a car in 5.5 years. Okay, so example 7, how much should you deposit now in order to have 100,000 in 10 years? And the money is kept in the account yielding 6.28% compounded monthly. So similar to the previous one, right? You only have 100,000 in 10 years. So now that's your financial goal. So the money is kept in this account yielding 6.25% compounded monthly. So again, ending balance is 100,000. Time T, that's 10 years. And then rate is 6.28%. And then compounding period is 12. Okay. So we just solving for P. So very similar to the previous one. So the ending balance equals principal rate over compounding period, which is 20. So ending balance is 100,000. Principal plus rate is 6.28% over 12. And 12 times years. 120 power. Right? So we're gonna divide both sides equation by the exponent to get P by itself. Power plus 6.8% over 12 raised to 20 power. Cancel that, so principal is by itself. So P equal to 100,000 over 1 plus 6.28% of 12 raised to 120 power. Let's see what that is. So one more time, we're going to use either Excel or calculator to solve this. We get 100,000 by 1 plus 6.8% of 12 and raised to what times 10? 120 power basically. So we get a result we get $53,453.27. So this is the initial investment principal, 53,453.27 double check, and 27 cents. Always remember to run it to decimal place, run it to the cent. Okay, and we're gonna look at some more sophisticated case like this one. Here, this one is solving for the at what interest rate compounding monthly will investment grow by 80% in 10 years and 5 months. So here we're solving for rate, interest rate R. Okay, so and also there's tricky things here. If the principal is not given, right? We just know the relationship between the ending balance and the principal. So it's growing by 80%. So easiest thing to do is assuming we have 1 unit. So the ending balance is principal plus interest, right? Plus the other one, 80% of the principal. So the ending balance will be 1 unit plus 80% of 1. That's 0.8. So 1 plus 0.8, that's 1.8. Meaning the ending balance is 1.8 times as much as the initial investment. We also know the time t. Time t is 10 years and 5 months. 10 years, 5 months, that's a 10 and then 5 over 12. We're going to turn it into an improper fraction. 10 times 12, that's 120, adding 5, 125 over 12 years. And compounding periods is compounding monthly, so n equal to 12. Now we have all the information here given. Let's just solve for the rate. Okay, so ending balance equal principal times 1 plus the rate. That's what we're looking for over 12 by NT. Hold on, let me just go back a little bit. Let me just write our formula first. Using the same formula here, R over N to NT. So A is 1.8 units. Okay, P principal is 1 unit, so it's 1 plus the rate. We're looking for that over. Number compounding periods per year 12. Compounding period per year 12 times 20. That's 125 over 12. As you can see, we're gonna cancel 12. That's why this is very crucial here. Step converting the time t to improper fraction. So here when we get a 1.8, so let's switch order. So it's 1 plus r over 12 raised to 125 power is equal to 1.8. And based on this one, we're solving for the r. So in order to get rid of the exponent here, we're going to do a reciprocal of 125, meaning we're going to raise it to 1 over 125 power. On the right hand side, do the same thing, 1.8 raised to 1 over 125 power. Okay. And as you can see, based on the a actually y, right, that becomes axy. Since xy are reciprocal, it becomes 1. So here we get a 1 plus r over 12. And these two cancel each other, so end up with 1.8 raised to 1 over 120 power. Now here we solve for r. First of all, we subtract 1 from both sides of the equation. End up with r over 12 equal to 1.8 raised to 1 over 125 minus 1. Eventually, you're going to multiply 12 from both sides of the equation and the result. So the rate should be equal to cancel 12. Rate is equal to that. Excel can result one more time calculator and Excel get a result. So here we end up with open parentheses 1.8 raised to 1 over 120 power minus 1 close parentheses and multiply by 12. And once you put in calculate the Excel properly, get the result right away. Right? So this again we run it 4 decimal place. So the result is 0.0566. 0.0566. 0.05. So it's 5.66. So that's really what we're looking at. So we're using some of the exponential properties and then get interest rate. Example 9. How long will it take for 20,000 to grow to 50,000 at a 3.75% compounding monthly? Okay, so here, as you can see, we're solving for time t. All right, so one more time, we are given initial balance, initial principal, which is 28,000. Ending balance is 50,000. Rate is 3.75%, and then compounded monthly, and 3.75% decimal is 0.0375, and then monthly compounding over 12. So one more time, the only thing we will know is time t. We'll solve for time t here. So step 1, we get our formula down. Ending balance equal principal times 1 plus r over n. And ending balance, that's 50,000 for 28,000. 1 plus the rate, it's 0.0375 over 12, and to the NT is 12. So right here, first step, we isolate the exponent. So dividing 28,000 on both sides of the equation, we get that. If you want to drop 3 zeros on the right to make it look simpler, that's okay. We can do that. So now reverse order, we're going to get 50 over 28 first. 1 plus 375 over 12 raised to 12t. So now we will taking the LM from both sides of the equation. LM on the left, we get 50 over 28. LM on the right, plus 0.375 over 12. 12t. Now 12t goes in front, so on the left is LM 50 over 28. 12 t goes in front, times LM of 1 plus 0.375 over 12. Now we solve for t by dividing both sides of the equation by 12 times ln of 1 plus 0.0375 over 12. Okay. 12 times ln of 1 plus 0.0375 over 12. Both sides of the equation. Cancel the ln, cancel the 12. So t is by itself. So t is equal to this. Let's see what that is. Right, so let's put into the Excel calculator out. So we get a equal to ln of 50 by 12 by 28 over parentheses 12 times ln of 1 plus 0.0375 and close parentheses, right? So here open 2, close 2. So here you get a result. This turned out to be 15.5 years. We run into 1 decimal place. So here we're talking about time t. So 15.5 years is about 15 years and then 6 months. So that's the timeline we're looking at for the money to grow from 28,000 to 50,000. And again, we use some algebra in terms of the exponential properties to solve it. Last one, tripling time. How long will it take an investment to triple in value at a 4.65% compounding weekly? And in the application of exponential function, when we talk about the population growth, we also look at the tripling time, and they are similar in nature. And we also dealing with the exponential function, exponential growth, triple. Here, so how long? That means we're looking for time to. Well, investment triple, so assuming principal is 1 unit, right? So any balance will be triple of that will be 3 units. And this assumption always works. Right? We're assuming 1 unit because we only need a relationship in terms of a number, right? Okay, so the rating here is 4.65%. The compounding period is weekly, meaning 52 weeks per year, 0.0465 in terms of the rate. Now let's solve for the time t, right? So very similar to the previous one. Okay, so any balance equal to principal times 1 plus rate over the compounding period. Remember, we only use two formulas in this section: simple interest formula and then compound interest formula. 3 units for 1 unit times 1 plus rate is 4.65% over 52, and then 52 times. Very similar. Reverse order first. 1 plus 0 5 over 2 is 50. Okay, for 3. So step 1, we're taking ln from both sides of the equation, ln of left, and plus 0.65 over 52 raised to 52. On the right is ln of 3. And 50t goes in front. Ln of 1.05 over 52. On both sides, okay, so we get that. So we put ln of 3 first. Okay, ln of 3. Now, in order to get t by itself, we divide 52 times ln of 1 plus 0.65 over 52. Both sides of the equation, 52 times plus 0.65 over 52. And cancel 52, cancel ln, and we get t on the left. Approximately equal to ln 3 over the denominator. So that is, eventually we do ln 3 by 52 times ln of 1 plus 0.0465 over 52 close parentheses, close another one. Okay, and that should do it. So if you enter, you get a result. So it's 23.6 years. So 23.6 years. That's the end result. And you want to do 23.6 years, turn into year and month. So that would be 23 years and 12 times 0.6 months. Because in a given year, there are 12 months. So 12 times 0.6 is 23 years and 7.2 months. So about 7 months. So that's how you do the conversion. You can also break it down. Let's say you do 0.2 months, you can 0.2 months is equal to 6 days. So 0.2 30 days by 6 days. So to be exact, it's 23 years, 7 months, and then 6 days. You want to exact. results. So again, this chapter we are using compound interest formula to solve a lot of financial investment problems. It's quite useful in personal life. So pay attention to this, do some work, and you'll get familiar with it.